Today, we're diving into the architecture behind a really cool travel app. But honestly, this is more than just a tech talk. It's a story about smart engineering, about building something complex piece by piece, and maybe more importantly, knowing when to stick with a simpler, proven solution instead of chasing the latest shiny thing. It's going to be good. And it all starts with this. The whole point of the Adventure Tube project, the why behind all the code, is beautifully simple. Let people put their travel stories right onto a map. This is the goal that drives every single technical decision we're about to unpack. So here's how we're going to break it all down. We'll look at the big picture engineering plan, and then we're going to walk through 5 different levels of development. We'll start at the very beginning, get into a pretty surprising plot twist, and then take a peek at what's still to come.
Right. You don't just wake up one day and build a massive system like this. It's a journey. And the team here had a really clear 5-level game plan to build out their microservices, adding more and more sophistication at every step.
And this just lays it all out so perfectly, doesn't it? You start with the fundamentals, a modular design. Then you layer on security. Then you make sure it won't fall over, resilience. Then comes a huge decision about the tech stack. And finally, you plan for controlling traffic down the road. It's a logical progression. So let's jump into level 1.
All right, level 1, this was all about getting that foundation just right. The whole idea was to build a system out of small, independent services where each one has one job and does it well.
And that leads to the million-dollar question that every microservice architecture tries to answer. How do you avoid building one giant, clunky thing, a monolith, where one tiny change means you have to test and redeploy the entire application? Well, the answer is all about separation of concerns. And this is just a perfect example of what that means in practice. You see, the auth service, it only cares about who you are. The member service, its whole world is your user profile. Geospatial handles all the map stuff, and the web service is just the front door for the public. The beauty of this is that any one of these can be updated, scaled up, or even completely rewritten, and the others just don't care. They keep on chugging. So the foundation is solid. What's the next logical step? Security. Because it's one thing to let people into your system, but it's a whole other thing to protect the stuff they create inside it. And this was a massive vulnerability waiting to happen. See, having a valid login token, a JWT, proved you were a real user, for sure. But it didn't prove you were the owner of the adventure story you were trying to edit or delete. Anyone could mess with anyone else's stuff. That had to be fixed, and fast. The fix was actually super smart and effective. Here's how it works. A request comes in to change some content. First, the auth service grabs the user's email out of their token. Then it goes and gets the content they're trying to change from the database. And here's the key. It compares the email from the token with the owner email stored with the content. Do they match? Great, you're in. They don't? Access denied. Simple, clean, and totally secure. Okay, so our system is modular, it's secure, but what happens when something inevitably breaks? Level 3 is all about making sure that one little service having a bad day doesn't take the entire platform down with it.
This slide shows you the absolute nightmare scenario on the left. Before this fix, if the member service failed, the auth service would call it, wait, then timeout, and fail too. That's a cascading failure, a domino effect that can crash everything. The after is the fix, a pattern called a circuit breaker. Now, if the member service starts failing, the breaker just flips open and instantly starts rejecting new requests. It contains the damage and protects the rest of the system.
And this isn't some kind of magic, it's all based on really specific rules. You can see them right here. The system is watching the last 10 calls. If half of them fail, boom, the circuit opens. It then waits for 30 seconds. After that, it carefully lets just 3 test calls through to see if the other service is back online yet. It's a really controlled way to handle failures. Now this is the really clever part. The circuit breaker is smart enough to know the difference between types of errors. It's set up to completely ignore what we call 4x client errors, like if you search for a user that doesn't exist. That's not a system failure, right? That's just a bad search. But it pays very close attention to 5x server errors, like the database going down. Those are the errors that count towards tripping the breaker. It's a crucial distinction. Okay, and now we get to my favorite part of this whole story. This is the moment where the team had to make a really tough call to pivot away from a super modern, popular technology because it just wasn't the right tool for the job. So the team knew they needed to handle a ton of users, right? So they adopted this thing called Spring Web Flux, which is a reactive framework. The big promise of going reactive is that you can handle way more traffic with the same amount of hardware. But how does that even work?
This is probably the best way to think about it. Imagine a traditional system is like a pizza delivery driver who goes to a restaurant and just waits there until the pizza is ready. They can't do anything else. A reactive system is like a driver who drops off the order, gets a ticket, and immediately leaves to go make another delivery. When the pizza's ready, the restaurant just signals that it's done, and any free driver can swing by and pick it up. No one is ever just sitting around idle. It's way more efficient.
But, and this is a huge but, this super modern, efficient system had a fatal flaw. They used a tool called Kafka for streaming events, and the digital breadcrumbs that let you see how a request moves through all the services, they just vanished. The traces were gone. They were completely flying blind.
And man, they tried everything to fix it. They used the official reactive library for Kafka. Nope, no traces. They tried to manually force the tracing information in there. Still didn't work right. They even tried mixing old and new libraries, building these complex bridges, and it was still unreliable. It was a dead end. The problem was just a fundamental conflict between how reactive programming works and how the tracing system works.
And this is where it gets brilliant. The solution wasn't to try another complicated fix. It was to go backwards. They ripped out the complex reactive web flux and went back to the simpler, classic Spring MVC. But, and here's the twist, they powered it up with a brand new feature from Java 21 called virtual threads. So they got all the scalability benefits of reactive, but with code that was way simpler and easier to debug. And just look at these numbers. The pivot didn't just fix the bug, it made everything ridiculously better. The missing Kafka traces? Perfectly visible now. The time it took to process a request, it dropped from 106 milliseconds all the way down to 6.5. That's about 6 times faster. It's such a powerful lesson in choosing the right tool, not just the newest one. So the system is stable, it's secure, it's fast, and you can actually see what's happening inside it. What's left on the roadmap? Well, the final level is all about adding the ultimate layer of control. The next move is to put a rate limiter right at the front door, the API gateway. They're planning to use a super fast tool called Redis to act as a traffic cop, deciding exactly how many requests can come in per second. This is huge for preventing a flood of traffic, whether it's malicious or just a sudden spike in popularity, and it keeps the system stable for everybody. And that really brings us to the big takeaway from this whole journey. That whole reactive pivot story leaves you with this question, right? In a world that's always buzzing about the next new framework, maybe the most valuable skill an engineer can have isn't knowing all the new stuff, but having the wisdom to know when a simpler, proven path is actually the smartest way to go.